Could we kill a modern submarine with an underwater A-bomb? In theory, yes. But what would be the fatal range?
Could be made of the maximum range at which lethal hull-splitting damage to a typical submerged target submarine could be assured. We were to determine the peak pressure and pressure time fields in water and in air. We were to evaluate the surface effects with particular regard to their influence on delivery tactics. We were to determine the equivalent yield of the weapon used, the dispersion of radioactive contaminants, and the oceanographic factors affecting transmission of the shock wave. The location for the Wigwam experiment was chosen for several reasons. From a purely scientific point of view, we wanted to create simple experimental conditions, avoiding any complications that might adversely affect our data. At Crossroads, we fired an atomic weapon at mid-depth of relatively shallow water. For Wigwam, the test depth was 16,000 feet, with 2,000 feet of water above the point of detonation. In addition, our test site was located within what proved to be a biological desert, far from sea lanes or land masses. In order to learn what a shock wave of such long duration would do to a submarine, we had to build special gauges, exactly similar devices in which the gauge variations would be smaller than the variations in gauge environment. Originally, it was planned to use actual United States submarine types for our experimental targets. However, this plan was rejected on the basis of availability, handling complexity, non-uniformity, and cost. Our need to compromise between an actual sub and a simple pressure gauge evolved the squaw. In concept, the squaw design possessed a composite of the most important structural features of the modern submarines of the world.